Welcome! Ever wondered how machines learn and make complex decisions? It all starts with neural networks, the core technology powering modern artificial intelligence. In this video, we'll break down what neural networks are, how they work, their structure, and their incredible applications across various fields. Simply put, a neural network is a computational model inspired by the structure and function of the human brain's interconnected neurons. This biological inspiration allows neural networks to learn from vast amounts of data, recognize patterns, and make predictions or classifications, much like how our own brains process information. Now let's look at the basic building blocks that make up a neural network. Neural networks are organized into layers. The input layer takes in data. One or more hidden layers perform the computations, and the output layer gives the network's final result. These layers consist of individual processing units called neurons, or nodes. Information flows from one layer to the next through these weighted connections. The real magic happens in how these networks learn. It's an iterative process of refinement. Learning is controlled by weights and biases. Weights determine the strength of the influence a neuron has on the next, while biases help adjust the output along the way. An activation function introduces nonlinearity, determining whether a neuron's input is significant enough to be passed on to the next layer, making complex learning possible. The network learns through a training process involving forward propagation to get a prediction and backward propagation to adjust those weights and biases based on the error, minimizing mistakes over time. Neural networks are not just theoretical. They drive many technologies we use daily. From tagging faces in photos to powering self-driving cars, neural networks excel at image recognition and computer vision tasks by interpreting visual data. Natural language processing, or NLP, allows machines to understand, interpret, and generate human language, making tools like voice assistants and translation services possible. Neural networks are powerful for analyzing historical data to make accurate predictions, utilized in everything from financial forecasting to weather prediction. There are several specialized architectures, each designed for specific tasks. Convolutional neural networks, or CNNs, are best known for handling visual imagery by processing data through specialized convolutional layers. Recurrent neural networks, or RNNs, are designed for sequential data, making them ideal for tasks like speech recognition and time series forecasting. So we've covered the basics of what neural networks are and how they operate. Neural networks are fundamental to modern AI, enabling machines to learn complex relationships and transform industries. As computing power grows, neural networks will only become more sophisticated, driving even greater breakthroughs in technology and innovation.